So in this exercise, we're given a simple network. We're actually shown the connections, the branch connections between some nodes. And we're given some of the information as far as current and voltage relationships between these. But we do have some unknowns. We do have unknowns in IA, IB, IC, and ID. So the first thing we're going to need to do is determine what the values of those are. We have assumed directions, but we'll need to determine what the magnitudes of those are. And then once we have that information, we should have enough information then to calculate the power absorbed or generated by each branch. So let's get started with that, with trying to determine what these currents are. So to do that, we're going to take node by node here. So we look at this node first, and when we do, we see that there's only two paths in or out of this node. So we have this path here, and we know 1 amp's coming in there. And we have assumed direction of current flow this way. But remember, energy must be conserved, which means that current must be conserved. So that means the sum of all currents entering and leaving a node must be 0. So if we have 1 amp coming in here, that means we must have 1 amp leaving here, that's in the opposite direction of what we assumed. So therefore, it will be negative. So ID in this case is -1. So that gives us one of them. So now let's look at a different node now. Now we want to look at this node here. So in this case, again, we know we have 1 amp leaving here, and we know we have 2 amps leaving this direction, and we have an assume going in. So if we have 1 leaving and 2 leaving, that's 3 amps leaving the node. So that means we must have 3 amps entering the node. So that being the case, when we look at that, that means that our IB is going in the direction we assumed, and it should be 3 amps. All right, 2 more to go. So the next node we want to look at will be this node here. So when we do that, we just calculated that there's 3 amps going this way, and we know there's 1 amp coming this way. So if we have 3 leaving and 1 entering, means we have to have another 2 amps entering to conserve current, conserve energy. Well, this is in opposite direction of what we show IC, so therefore it'll be negative, and so that's a -2. All right, so now that just leaves one current left to calculate, and so what we want to look at here will be this node. And this node should give us our final current. So in this case, we've already determined that for this ID, it's negative, so that means there's 1 amp coming in there. Also for IC, it's negative, and there's 2 amps coming out that way. And there's only one other path, so remember, energy must be conserved again. If we have 2 coming out, we should have 1 and 1 going in. So we should have 1 amp coming in here. Again, that's in the opposite direction of what we're showing. So therefore, IA should be -1. So now we have determined all of our currents here that we're missing. So now we need to look at each branch separately and determine what the voltage relationship and current relationship is between them, and then we use that to determine if power is generated or absorbed. So first, we want to define what the branches are. So we want every branch. So we'll start with node 1. So it doesn't make any sense to look at relationships between 1 and 1, so we'll go between 1 and 2, 1 and 3, 1 and 4, and 1 and 5. So there's 5 total nodes. So now we want to look at, in relation to 2, it doesn't make any sense to go between 2 and itself. We've already done 1 and 2 here. So we start with 3, 4, and 5. So again, start with node 3. We've already done 3 and 1. We've already done 3 and 2. 3 and 3 doesn't make any sense. So 3, 4, and 3, 5. So now we want to see about 4. We've done 4, 1. We've done 4, 2. We've done 4, 3. Doesn't make sense to do 4 in itself, so we're left with 4 and 5. So that should be all of the nodes that we need to analyze. So next, we want to determine what the current relationship between each of these nodes is. So now, if we look at 1 and 2, so let's use a different color here. So we're looking at between 1 and 2. So we know that the current flow is IA. Well, IA in this case is a -1. So now we're going to look at 1 and 3. So here's 3 here. So the current flow between those is IC. And we're actually going from 1 to 3, so the current is negative, but it'll be flowing in the direction that we're going, so it'll be a +2. Next, we'll be looking at 1 and 4, so 4 is down here, and that's going to be ID, and again, that one's negative, so that's a -1. And finally, we have 1 and 5, so 5 is over here, and there's no direct connection between those two, so therefore, we're going to say that there really is no current relationship directly between those two. So that takes care of all the connections involving node 1. So now we're going to start with node 2. So between 2 and 3, we see current flows from 2 to 3, 1 amp. So that's a +1. Between 2 and 4, which is right here, there is no direct connection. So therefore, that would be 0. Between 2 and 5, which is over here, between 2 to 5, we have 2 amps flowing, but it's flowing against our node number 2. So therefore, that value would be a -2. And then between 3 and 4, which is down at the bottom here, there is no direct connection. So therefore, no direct current flow between them. And then we'll go between 3 and 5, which 5 is over here. See that is IB, and IB is 3. So therefore, that value is 3. And then finally, between 4 and 5, so that's between these two here, we see that there's 1 amp, but it's flowing back into our node, so therefore it'll be a -1. Okay, so that takes care of our current relationships between all these nodes. Next, we need to look at voltage relationships between these nodes. So to do that, we want to create another column for voltage. So first we want to look at between 1 and 2, so between these two nodes, and we see right away that that's 6 volts between those two, right there, so we take care of that. So next we want to go between 2 and 3, so that's between these two. Now here we see that there is no information is directly between 1 and 2. There's nothing here telling us the voltage relationship there, but we can get there via a path that we do know. So when we start at 1, we see that we have a +6 volts from here to here, and then to get from here to here, we see them hit the negative sign first, so that's a -4. So therefore, the sum is 2 volts. So there will be a 2-volt difference between those two. Next, we're going to go between 1 and 4, which is here. And again, we have no direct voltage relationship there. So again, we're going to start here. And let me sum this up again. So we go from here to here. We know that that is 6 volts. Then we go from here to here. We know that that's -4 volts. Then we go from here to here. That's -8 volts. So when we add that up, we should get a -6. So that's what goes in this place is -6. All right, so next we will have between 1 and 5. 1 and 5. So again, no direct connection, but again, we're going to utilize information we know about other nodes. So we go from here to here. We will have another 6 volts. And this time we're going to go from here to here. We hit the plus sign first, so that's 3 volts. So therefore, this guy will be 9 volts. It adds up to 9 there. All right, so we're making progress here. So that takes care of all of our nodes in relation to node 1. So next, we want to start with node 2. We can go between 2 and 3. So we see here, if we go between 2 and 3, we know that one directly. And that's just -4. So we hit the minus sign first, starting at 2. Okay, so next we want to go from 2 to 4. So that's down here. So we got to find a path on this one, right? And we have one. Again, we go from here to here. That's -4. And then we go from here to here. That's -8. So that's -12. So now we'll put -12 here. All right. So that takes care of that one. So finally, we're going to go from 2 to 5. And that one's gives us that one directly. That's just a +3. So we'll put a 3 here. And that takes care of all of our relationships involving node 2. So now we want to go to node 3, and we look between 3 and 4. And again, that one's given to us directly. So it's a -8 because we start at 3, and there's a negative sign at 3. That's how we determine the sign. And then next we're going to go between 3 and 5, which is here. So between 3 and 5, again, we don't have direct information on that one, but we can find a path. So if we go this way, that's going to be a +4 because we have a plus sign first, and then we go from here to here. That gets us to 5, and that's a +3. So that total is 7. So then we'll put a 7 here. And that leaves us with one node relationship left, and that is between 4 and 5. And so between 4 and 5, again, there's no direct information shown here along the direct path, so we'll have to take an indirect path. And when we do that, we'll go this way. So here to here, that's a +8 volts. From here to here, that's a +4 volts. And then from here to here, which gets us to our destination, that's a +3 volts. So we add those up, and that's 15 volts. So that'll be our final voltage that we need. Okay, so now we have all of the voltage and current relationships between all our nodes. So now what's left to do is we can calculate the power absorbed. And so let's erase this. And we'll have power absorbed. And so When the product is positive, it goes into this column, and then we'll have power generated, and that's when it's negative, goes into this column. So now we just simply multiply across, and when we do, if we have a -6, it goes over here, a +4 goes here, a +6 goes here. This would be 0. We have a -4, so it goes here. And then we have another 0, so nothing from that one. We have a -6, so it goes over here. Again, we have 0. We have a 21, which goes here. And then we have a -15, goes over here. So now we should be able to add these up. So we add this column up, we get 31. And when we add this column up, we also get 31. So therefore, our energy was conserved and everything checks